In episode 27, titled Spaced Review, Acquisition and Preparation Recall Without Notes or Shortcuts, the narration shifts into a fast spoken style review that strengthens memory without relying on notes. The goal is to keep the skills in working memory long enough that they show up automatically under exam pressure, especially when a question stem is short and the distractors sound plausible. The review stays anchored to the same acquisition and preparation moves already covered, but it compresses them into quick recall cues that still protect meaning and trust. The tone is deliberately practical because these topics are most useful when they feel like mental reflexes rather than definitions. Each paragraph builds one mental hook, so the full sequence becomes a clean rehearsal you can repeat later. Preparation skills start with an idea that feels simple but carries the whole domain. Every change in data handling is either preserving truth or bending it. Collection choices decide what exists in the dataset, which means they decide what questions can be answered honestly. Pipeline choices decide where rules are enforced and where ambiguity is allowed to persist, which changes how quickly errors surface and how consistently results can be reproduced. Quality checks decide whether a number is evidence or just output, because the same calculation can be correct on corrupt inputs. Feature work decides what signals are visible, because raw fields rarely line up with the story that analysis needs to tell. ETL and ELT differ most clearly in where transformation happens relative to storage, and the cleanest recall is to picture where mess is allowed to live. ETL, extract, transform, load, reshapes and standardizes before the destination receives the data, which tends to protect downstream systems that require strict conformity. ELT, extract, load, transform, lands raw or lightly prepared data first and performs transformation inside the destination, which often supports flexibility when storage and compute can handle evolving models. A single example keeps it sharp. When a reporting warehouse must only contain curated tables with stable definitions, ETL fits because the rules run before load, while a modern warehouse with a raw layer and multiple modeled layers often fits ELT because the raw history is preserved and new transforms can be added later. The recall cue is that the letters are a timeline, and the placement of T is the main difference that affects governance, iteration speed, and where errors hide. Missing values become dangerous when the dataset still looks complete enough to compute metrics, because missingness changes the sample silently. Missing, null, blank, and zero are not interchangeable states, and treating them as the same creates false patterns, such as interpreting unknown revenue as zero revenue, or interpreting an empty string as a known value. Missing this patterns form along real boundaries like time, region, device, channel, or system version, and those boundaries often reveal collection or pipeline issues rather than real-world behavior changes. A fast mental test is whether missingness appears clustered, because clustered missingness behaves like a hidden filter that reshapes the population being analyzed. When that happens, the dataset can produce crisp averages that are still misleading because the underlying comparison groups are no longer comparable. Duplication and redundancy are easy to confuse because both involve repetition, but they carry opposite implications for cleaning. Duplication is multiple records representing the same real-world event or entity, which inflates counts and sums when each record is treated as unique. Redundancy is repeated information that exists on purpose, such as a customer attribute copied into a transaction record to preserve point-in-time context, performance, or auditability. The overcleaning risk appears when redundancy is mistaken for duplication, because removing repeated information can erase history or break the ability to reconcile outputs later. A quick recall cue is that duplication creates extra reality that never happened, while redundancy preserves reality in more than one place so it remains explainable when systems change. Outliers are not automatically wrong, but they are automatically suspicious because they can either be rare truth or measurement failure. False spikes often come from unit changes, scaling mistakes, or software defects that begin at a boundary like a release date or a new data source, and they show up as a sudden cluster of extreme values rather than a smooth tail. Another common cause is interpretation drift, such as treating cents as dollars or milliseconds as seconds, which creates values that are off by a consistent factor and dominates summary statistics. Group-based comparison keeps recall grounded because an outlier that is impossible in every segment is more likely a defect, while an outlier that is extreme overall but normal in a specific segment may be legitimate. The memory hook is that outliers demand a plausibility check tied to process reality, not just a mathematical threshold. Text cleaning is a pipeline in miniature, moving from raw strings to standardized representations that support matching and grouping. The first moves are usually trimming and consistent casing, because invisible whitespace and inconsistent capitalization create false uniqueness and broken joins. Parsing follows when a string contains multiple concepts, such as codes mixed with names or dates embedded in file names, because the best way to validate meaning is to separate it into dedicated fields. Regular expressions, written as regular expressions, REGEX, on first mention, are best recalled as pattern tools for stable structures, not as complicated riddles that only one person can maintain. The final aim is standardization through controlled vocabularies and mappings, while keeping raw text available for traceability, so the cleaned value can always be tied back to original evidence. Reshaping moves are powerful because they change the table form, but the safety rule is that reshaping must not change totals unless there is a justified, understood reason. Merges require key confirmation and row count expectations because a one-to-many join can multiply rows and inflate measures even when the join syntax is correct. Appends require meaning alignment because identical column names do not guarantee identical concepts, units, or allowed values. Exploding nested fields into rows is useful for analysis, but it creates duplication risk by changing grain, which can repeat product-level measures across multiple rows unless measures are recomputed at the right level. A quick recall checkpoint is that every reshape should have a before and after validation plan that includes counts, totals, and a small sample walkthrough. Feature creation translates raw data into signals, and the recall focus is on making variables more comparable, more meaningful, and more predictive without becoming opaque. Binning groups continuous values into ranges that reflect context, not arbitrary equal splits, so bins align with how decisions are actually made and how processes behave. Scaling helps when variables span different magnitudes, because large-scale features can dominate methods that depend on distance or combined influence, even if the large values are not more meaningful. Imputation can keep datasets usable, but it works best paired with a missingness flag, so the analysis can know a value was originally absent and treat that fact as information when it matters. The anchor rule is that every feature should remain interpretable enough to explain, because explainable features support trust and make debugging possible. Leakage is the feature risk that makes results look excellent while being unusable, because it sneaks future information into variables that are supposed to predict or explain outcomes. Leakage can be blatant, like including a cancellation date while predicting churn, or subtle, like using an aggregation window that extends beyond the decision point and captures consequences as predictors. The fastest recall test is temporal discipline,
meaning each feature is checked for when it becomes knowable relative to the outcome and the moment the analysis claims to represent.
Leakage also appears through proxy fields that only exist after an event, such as a resolution code created after an incident closes, which can turn a prediction task into a disguised labeling task.
The memory hook is that leakage breaks causality, so it produces confidence without reliability.
A merge decision becomes easier to rehearse using a simple two-table story that forces identity thinking without getting lost in implementation detail. One table represents orders with an order identifier, a customer identifier, and a total amount, while the second table represents customers with a customer identifier and a region label. A safe merge begins by confirming the customer identifier has the same format in both tables, including leading zeros, casing, and type, because a mismatch turns a merge into silent missingness. The next thought is the expected relationship, where many orders should map to one customer, which implies the order table row count should remain stable while customer fields repeat across orders. The final thought is what changes if the merge fails, because unmatched customers create null regions that can distort analysis by region even while overall totals look correct.
Quick validation is a habit, not a one-time effort, and it relies on counts, totals, and small samples as complementary evidence. Counts confirm whether the number of rows and the number of distinct identifiers behave as expected after merges, appends, and explosions, because unexpected growth or shrinkage often signals duplication or filtering.
Totals confirm whether key measures like revenue, quantity, or event counts remain stable when form changes, which is essential when reshaping is supposed to preserve truth at a given grain.
Samples confirm meaning, because a handful of end-to-end record checks can reveal mismatched keys, incorrect parsing, or repeated measures that totals alone might not explain. The recall cue is that counts tell scale, totals tell conservation of meaning, and samples tell whether the story still matches the real process.
Several common pitfalls consistently break trust in results because they create errors that look like real insights until someone challenges them. Blindly dropping rows with missing values can change the population in a clustered way, which turns missingness into a hidden segmentation filter that biases conclusions. Treating identifiers as quantities or allowing silent type coercion during reshapes can cause joins to fail and categories to fragment, producing misleading trends that are really data handling artifacts. Overcleaning text can collapse meaningful distinctions, while undercleaning text can split one concept into many labels, and both failures can distort counts without obvious warnings. The guiding idea is that trust breaks when the dataset stops representing the underlying process consistently, especially when changes happen silently and cannot be traced. Memory improves when concepts are compressed into short sentences that can be spoken smoothly, because recall is strongest when it is rehearsed in the same form it will be used under time pressure. ETL means transform before load, which protects strict downstream conformity, while ELT means load first, which supports flexible transforms near the data. Missingness is information, so null, blank, and zero must not be merged into one state, and patterns by time or device often reveal measurement gaps. Duplication adds fake reality. Redundancy preserves context, and outliers demand plausibility checks that often point to unit shifts or bugs. Text cleaning moves from trim and case to parsing and patterns to controlled mappings, while reshaping is validated by conserving totals and preserving grain, and feature work stays useful only when it avoids leakage and remains interpretable. The review closes by naming 3 weak spots for tomorrow in a way that keeps them concrete and tied to observable mistakes rather than vague goals. One common weak spot is key discipline during merges, especially around leading zeros, type mismatches, and one-to-many joins that multiply measures. Another weak spot is missingness reasoning, where clustered gaps by device or time are treated as random and rows are dropped without measuring who gets excluded. A third weak spot is leakage awareness during feature creation, where future-coded fields or overly broad time windows slip into derived variables and produce results that are impressive but not trustworthy. Naming weak spots in this specific form matters because it connects memory to failure modes that can be recognized quickly on exam questions.
The conclusion of episode 27 assigns a 5-minute drill that reinforces recall without notes by rehearsing a single clean chain of reasoning from acquisition through preparation. The drill can be framed as speaking through one small dataset story, such as orders joined to customers, while stating what ETL versus ELT would change about where transforms occur and where checks are enforced.
The rehearsal then names one missingness pattern to look for, one duplication risk created by reshaping, one text standardization choice, and one feature that avoids leakage by respecting time order, all stated as plain sentences tied to the story.
A final pass states what would be validated with counts, what would be validated with totals, and what would be validated with a small sample review, because that triangulation protects meaning. Done consistently, this short drill makes the concepts feel automatic, which is exactly the point of spaced review in acquisition and preparation.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.